In this example, let's go ahead and find the integral here. And so we have the integral of the square root of 6 minus the square root of x minus 2. So we kind of have embedded radicals in this expression. And then, of course, we're doing it with respect to x. So it looks like we're going to need a u substitution. So let's go ahead and make u the entire expression underneath this original or the big radical. So let's say u equals 6 minus the square root of x minus 2. Okay, well, when I differentiate both sides, I'll have du equals, it looks like negative 1 over 2 times, and then the square root of x minus 2, and that's dx. Well, to solve for the dx here, to make this substitution, let's go ahead and multiply both sides by negative, and then 2 times the square root of x minus 2. So I have negative 2 times the square root of x minus 2 du. Okay, so that's kind of what my dx is with my original u. So let's go ahead and plug things in and see what this looks like. So I have my integral here, and it's going to be the square root of u, because u is this entire thing. But when I go to exchange and substitute my dx in, this doesn't look very nice. Okay, it looks like that. Well, I've got a problem because I've changed almost everything to u's and du's, but I still have this x right here. Well, let's go back to my original u substitution that I made. U equaled 6 minus the square root of x minus 2. So let's go ahead and solve that for the square root of x minus 2, and then we can go ahead and substitute that. And that'll be in terms of u then. So this is a negative square root of x minus 2, so let's go ahead and shuffle that over to the left side where he'll be positive, and then let's bring that u to the right side where he'll end up being negative. So I have the square root of x minus 2 equals 6 minus u. So this 6 minus u I can now plug in right here. So let's kind of go ahead and see what that looks like now. So I have my square root of u times negative 2 times 6 minus u du. So let's go ahead and do some simplification then now. So I can make this negative 2 come out here with the square root of u, which I can distribute through the 6 minus u, just like that. So this ends up being negative 12 times the square root of u minus, and then minus a negative, so plus 2 times u times the square root of u du. Okay, well, let's rewrite this using rational exponents, because that'll be a lot easier than to integrate. So negative 12 u to the 1/2 plus 2 times u to the 3/2 du. Well, not so bad at all. Okay, so let's integrate, and we'll go one term at a time. So this negative 12 u to the 1/2 will add 1 to the power, so the 1/2 becomes 3/2. And we had our negative 12 out front here. And of course we need to divide by that new power, so we're dividing by 3/2, which is really multiplying by 2/3. And we'll come back through and simplify that. Let's go ahead and look at the second one. So plus 2u to the, we'll add 1 to the power, so now it's 5/2. We'll divide by that new power, which is really dividing by 2/5, and then plus c. Okay, so let's just do a little cleanup work here. So the 12 and the 3 can cancel and become 4 and a 1, respectively. So we have negative 4 times 2 is negative 8, u to the 3/2, plus, looks like 2 times 2 is 4 over that 5, u to the 5/2 plus c. And then what was the expression I used for u? Well, it was 6 minus the square root of x minus 2. So let's go ahead and replace that. 6 minus the square root of x minus 2 to the 3/2 plus 4/5 times 6 minus the square root of x minus 2 to the 5/2 plus c. So here would be our integral, this expression right here. Okay, so here was our answer. And of course you see it's not really great. I wonder if we can use some algebra to manipulate that, to clean that up a little bit. Because you know in a lot of these calculus textbooks, maybe you check your answer in the back of the book and they have something that looks really clean and nice and tidy and you're like, how in the world did they get that? So let's go ahead and maybe do some manipulation and see if we can tidy this up a little in the same way. So it looks like we have this expression 6 minus the square root of x minus 2 in both of these terms. And our exponents are 3/2 and 5/2. So let's go ahead and factor out the 6 minus the square root of x minus 2 to the 3/2 and kind of see what it is that we have left. So we'll have a -8 from the first one, and then we'll have plus 4/5 times, and then once I factor the 3/2 out, really I just have 2/2 or 1 left over. So it looks like this. And I can distribute through here, and that will be a little nice. Okay, so -8 plus, looks like 24/5 minus 4/5 times that square root expression. Okay, so this inside bit, let's see, the -8, and we have 24/5. I can make this -40/5. And then -40 plus 24 is -16/5 with my 3/2 here. Okay, and then our plus c, of course. Don't want to leave that guy out. So we have two terms inside here, this guy and then this guy. Looks like they both have a denominator 5, and they're both negative, and they both have 4's in the numerator that I could cancel or factor out. So let's go ahead and factor out a -4/5. And then we'll have our 6 minus the square root of x minus 2 to the 3/2 right there. And what will I have left over? Well, when I divide -4/5 out of this, I have 4, and then plus the square root of x minus 2 plus c. So I'm not sure if that cleans that up much from this original, but at least instead of having two terms with rational exponents, we only have the one, and it kind of makes it a nice factorization here, or we're multiplying, and we took that -4/5 out, so our coefficients here aren't nasty. So anyway, so using this algebra to kind of manipulate this and try to clean it up a little, it's interesting to do, and some fun too. So there you go, there's the answer for that integral.